Let's start over. At MoU Religion, I Love Maths says, good stuff, but when will you post a new video? Well, the short answer is right now. The long answer is that, unlike most science YouTube channels, I mostly talk about science I developed myself, so it takes me a while to do the work of inventing the science and then talking about it. So I've been busy. You all know that I spent 10 years working out how to divide by zero. And then I spent the last 8 years working out how to extend mathematics so that it doesn't fail either. And I've written the Principia Transmathematica that explains how to do mathematics so that it is not guaranteed to fail. It's a small book. It's written in English. From my YouTube statistics, I know that about 20% of my audience are native speakers of English, and about 80% of my audience are learners of English. If you've learnt English to C1 level, then you'll be able to read the whole book. If you've read the book to B2 level, then you'll have to focus on individual parts. So you will be able to read the introduction. The introduction says what the difference is between a partial system of mathematics and a total one. That's 1 page long. With a dictionary, you will be able to read that. The section on Transreal Arithmetic is about 10 pages long. As long as you can do fractional arithmetic in your mother tongue, you'll be able to understand what's going on in the section on Transreal Arithmetic. And the same with the section on Trans-Newtonian physics. If you understand Newtonian physics, you'll understand how I've extended Newtonian physics to allow division by zero and work at singularities. The epilogue, that's right at the end of the book, is just 1 paragraph long, and with a dictionary, you'll be able to understand that. So let me tell you what's in the book. Start off with an introduction, of course. And then there is a section on totality, explaining the importance of mathematical systems, physical systems that always work. And in writing this book, the Principia Transmathematica, I've gone right down to the foundations of mathematics. I've said, what does it mean to totalize a symbol? Mathematics is written in symbols. Normally the symbols are discrete, and there are a finite number of them. And I generalize the idea of a symbol to being a continuous symbol and a continuum of symbols. There are infinitely many symbols. And I show you how to encode all written knowledge on the unit line from 0 to 1. That's a neat trick. It's been done before. I'm told that it is the theme of a science fiction book. If you recognize which science fiction book it is, then do tell me, and I'll give a thanks to you and reference to whoever the author was. So the second chapter, second section, is about totalizing logic. So the logic that mathematics usually uses 2 symbols, false and true, but it's missing 2 combinations. The combinations are false and true, which is a contradiction, and neither false nor true, which is a gap. Because mathematics usually uses that binary system of logic, which is partial, is missing 2 systems, the logic of mathematics is guaranteed to fail on contradictions and gaps. Now, mathematicians know this. When mathematics fails in those ways, They generate some more complicated mathematics and explore that. But they usually do it with the binary logic, which is missing two states, and they fail again somewhere. Now, it's perfectly reasonable to use the logic that mathematics does, build up a system, find a problem, build a better system, find a problem, build a better system, find a problem, and go on forever. That's a way of spending your time. But there is another way of proceeding, which is to totalize the logic so that it uses true, false, contradiction, and gap. Now, in the discussion of that logic, you will find that confirmation bias is normally thought to be a fallacy of logic. So you get a bit of evidence for something and you believe it despite the contrary evidence. It turns out that that confirmation bias is a total unary logic, a logic that has the values, for example, true and gap. So you can accept evidence in favor of the things you believe true, and you will ignore all evidence against you gap. And you can build up the four-valued total quaternary logic from this total binary logic. Sorry if I'm losing you in the discussion. If you buy the book and read it, you'll see what I'm on about. Set theory fails in various ways. And the reason for that is that set theory and logic are very intimately related. Anything that you can do in first order predicate calculus, which is a kind of logic, which includes the usual logic of mathematics, you can do in set theory and vice versa. So there's a one-to-one mapping between set theory and the first order predicate calculus. And so set theory fails for the same reason that mathematical logic fails. It fails, for example, on contradictions. And the famous case is the paradox of Russell's set, which contains all sets that don't contain themselves. That has the consequence that if the Russell set itself is in itself, then it can't be, and if it isn't, then it must be. And that is a contradiction which is handled by a transet. I'll show you a quick picture of a transet. There we go. This is showing a cone. The base of the cone is the foreground. The apex of the cone is the background. So everything in the background is not being considered at the moment. The foreground base of the cone, it's got a boundary on it that divides the base of the cone into an inside and an outside. So we've got four parts: an inside, outside, boundary, and cone. And those correspond to the four logical values: true, false, contradiction, and gap. So again, we've built a one-to-one mapping between transet theory and translogic, and that means we're not guaranteed to fail because we consider all possible logical values, we consider all possible arrangements of transets. There is a section on philosophy of totality. When I'm doing transmathematics, when other people are doing transmathematics, when other people are doing different ways of making total systems, we are beginning to say something about how knowledge is handled, how science is done, what the possible interpretations of mathematical physics are for the physical world, what possible experiments we could do now that we know how to divide by zero, now that we know how to guarantee that logic doesn't fail. Basically, we can make mathematical physics work at singularities where other people can't. We can predict things that would happen at singularities. And in principle, we can test to see if our predictions are correct or not. And so the story of transmathematics is that it's not guaranteed to fail. We can take on any question. And that changes the way we do science, that there's nothing that is out of bounds. We can take on anything. We don't have to say, oh my goodness, our mathematics breaks down at singularities. We can't deal with the singularity in a black hole. That never happens. We can always say something. There is a section on transreal arithmetic, and you can learn transreal arithmetic from this section. It's about 10 pages long. There are 12 steps you need to take to go from fractional arithmetic you learn in primary or secondary school to get to transreal arithmetic. And if you are interested in transreal arithmetic, you could teach yourself from this book. The youngest person to teach themselves transreal arithmetic is 10 years old. 15-year-olds, I've taught 15-year-olds how to do transreal arithmetic in half an hour. So it won't detain you very long if you're a school teacher or a parent who wants to learn transreal arithmetic in order to teach children, their own children, about it. I'll give you a picture. So there's discussion like this that's showing you how to do fractional calculations with division by zero. I am a little bit worried that this screen is going to be reversed left to right. Maybe I can fix that in editing, maybe I can't. And I need to do something about my camera. Yeah, here's more of this stuff. And then there is discussion of the empty symbol. Now, the empty symbol is what it sounds like. It's a symbol that doesn't exist. It's used in computer science. The idea is the empty symbol is known by a name, a meta symbol. The meta symbol is a non-terminal symbol that exists in the grammar and doesn't exist in the language you're writing. What that means in practice is you are expecting an answer in your head. There is no answer there, so you say the answer was the empty symbol. So here's an example. 0 to the minus 1 equals. There's nothing written after the equals. There it is. And so you write down 0 to the minus, I was expecting an answer, I write down 0 to the minus 1 equals the empty symbol. There we go. And now you can do algebra, set theory, logic on the empty symbol and work out how to divide by zero. This is a method that was discovered in 1957. It's written down in terms of the empty symbol. There are lots of ways of dividing by zero. There are infinitely many of them. So far as I know, transreal arithmetic is the only one that has been published that is coherent with calculus and therefore coherent with mathematical physics, coherent with finance, all of the sorts of calculations we do in real life. So that is the unique claim to transreal arithmetic, that it is useful. Okay, here's a discussion of transphysics. Now, you can just take the mathematical laws of physics, write them down in transreal arithmetic, and get an answer. But what does the answer mean? In order to interpret the answer, you need to know how the transreal number line relates to the things you're measuring in empirical physics. And this picture shows you how it relates. So here we have the transreal, here we have the real number line, we have the infinities for a gap, and we have nullity off the line. Now, this nullity above zero is just a drafting convention. What's really going on is that nullity is in a space outside of the extended real number line, which contains the real number line and the infinities. And that means that nullity never projects into the extended real number line. It never projects into the universe we live in. We know we don't live at nullity because nullity is unordered and it wouldn't be possible to move my hand left and right if we lived at nullity. So we live somewhere else. Well, where do we live? Well, we live somewhere in the extended real universe. Our experience tells us we don't live at infinity, we live at a finite place in between. This diagram shows you that nullity forces project into the extended real universe as if they were zero. In other words, they don't project in. And now, because you know how to calculate a nullity force, you can calculate all forces. You can calculate the finite forces. You already know what the infinite forces are. You know what direction they operate in. You know they operate at the maximum magnitude. And now you can calculate the effects of those maximum magnitudes using transreal arithmetic. So I've published it before, but I've made the explanation easier to understand. We generalized to Newton's three laws of motion and his law of gravitation. There's a bit of discussion of Einstein. So this is popular cosmology. I'm not claiming that physicists go very far in believing this, but you take Einstein's equation E equals mc squared, rewrite it as E minus mc squared equals zero, and now you can say that all of the energy and mass in the universe was created from zero. And physicists debate, is the universe finite or infinite? Well, the answer is blindingly obvious. If we create the universe this way, from E minus mc squared equals zero, all of the solutions to that equation are finite, therefore the universe is finite. There is another way of rewriting Einstein's equation E equals mc squared, which is E minus mc squared equals nullity, and now we can have infinite energy and infinite mass, and the universe can be infinite. Take that with a pinch of salt. All I'm doing is encouraging you to apply transmathematics to physics and see where you get to. There's a section on transcomputation. This is the 2's complement system. The 2's complement system is guaranteed to fail. It has a weird number where it's the most negative number. If you negate it, it stays negative. If you multiply it by -1, it doesn't turn positive, it stays negative. And those problems go away if you recode the bits as transreal numbers with a plus and minus infinity and a nullity. I have yet another shout at IEEE 754. This is the way that decimal calculations are done on computers. If you've got a number with a decimal point in it, you're working on it on a computer, almost certainly you're using IEEE 754 standard. The standard has the property that no nan is equal to anything, not even itself, and that breaks the law of identity. So the law of identity is one of the three basic laws of logic. When it's broken, the system is illogical. So it's not logically possible to specify floating point program in terms of floating point numbers. It's not possible for the computer to execute a floating point program in terms of floating point numbers. And it's not possible for a human or a machine at the end to test, to check that the behavior was what was expected. You can't even do the check. What you can do is, instead of using abstract floating point numbers, you can use the bit patterns. So providing you are willing to specify a floating point program in terms of the bits in the data, the computer can process the bits, and providing you're willing to check that the bits that were used were produced in the output match the bits you were expecting, then you can do that. What you can't do is take a proof from mathematics about some numerical calculation using real numbers and write that down using floating point numbers in a program. If you do that, you are guaranteed to fail. And that's bad news, because almost all of the calculations that we depend on are done that way. They are all guaranteed to fail, almost all. There are a few calculations you can do correctly. I've never seen anyone other than me who could write a correct floating point program, and most of the time I get it wrong too. There are an awful lot of nans in a 64-bit processor, which is what we normally use on our desktop computers. I'm not quite sure what a phone uses. Is it 32 or 64-bit? Anyway, at 64-bit, there are 9 quadrillion bit patterns that corresponds to NaN. When I started my research, that was 100,000 NaNs, 100,000 error states per star in the Milky Way galaxy. It is a truly astronomical figure. Telescopes have got better over my life. Astronomers now believe there are 4 times as many stars in the Milky Way as they used to believe. And so I say that there are 25,000 errors on your computer for every star in the Milky Way galaxy. So this is extremely bad news if you're using the computers to control your armies, to design weapon systems, to control weapon systems. It means that the people who use sans floating point arithmetic are going to outperform you. And here is the epilogue. It's very short. I'll read it to you. It does not matter if you read this book. It does not matter if you understand it. What matters is that your competitors and enemies are reading this book and they understand it.